This video is going to demonstrate how to do questions like this question here, where we have a function that is in fact a quotient. Now, I am fully aware that there is a rule for finding the derivative of a function that is a quotient, the quotient rule, but the Year 11 Maths B syllabus doesn't cover it. So we're going to be doing this question using a chain rule within a product rule. We're going to turn it into a product. So the question that I'm going to demonstrate with is from the exercise 8.5 for B. So I've started off by writing for B again on my page, and I've once again started with y equals to help my communication, and I'm going to remember that the variable within is r and not x. So if we're going to use the product rule, we first need to change y into something that looks like a product by bringing this function up to the top and giving it a negative power. So our new thing that we're going to differentiate is 6r minus 8 times 2r plus 9 to the negative 1. From now on, it's very similar to the process that I demonstrated in the other video about how to find the derivative of a function that is a product that has a chain rule within. But the last couple of lines are a little bit trickier because of the negative power. So let's just walk through it. Because it is a product, we need to identify the two parts, the two factors of the product. We're going to identify them as u and v, where v is the entire part including the power. And we're going to write those parts down here. So u is 6r minus 8, and v is 2r plus 9 to the negative 1. And du dr, a derivative of a function called u that has r in it, is 6. And dv dr, a derivative of a function called v that has r in it, is what we're going to use our chain rule for. So we're going to move up here, and we're going to identify the parts of this new function that we're going to differentiate using the chain rule. Once again, we need to make the inside function into another variable, which I usually call w, and once again I'm going to do all of this in blue. So our new function is called v, and it now has w in it, so it's w to the negative 1. Our inside function is called w, and it has r's in it. So the derivative of a function called v that has w's in it is negative 1 w to the negative 2, decreasing our power by 1. And the derivative of our function called w that has r's in it is 2. The chain rule says dv dr is equal to dv dw times by dw dr. These two have to match, and these two have to be the same as these two. dv dw is minus w to the negative 2 times by dw dr is 2. So we've got minus 2w to the minus 2. Now we slot back in the w function, which is that one, minus 2, 2r plus 9 to the minus 2. And that is going to go back over here. Minus 2, 2r plus 9 to the minus 2. Now we can continue on with our product rule. Our product rule says dy dr is v times du dr plus u times dv dr. So v is this 2r plus 9 to the negative 1 times du dr is 6, I'll put the 6 on the front, plus u, 6r minus 8, times dv dr minus 2, 2r plus 9 to the negative 2. So Now we need to look for a common factor. Remember, every time you have a chain within a product, it will always have some obvious common factors that you can factorise out. And they're usually to do with that function that you had to go off on a tangent to differentiate. So the 2r plus 9 to some power is going to be a common factor. We also have a 6 here, because these two parts of our sum are here and here. So this is the bits that we're looking for the common factors in, on either side of the equals. So we've got a 6 here, and we've got a 6 there, but it's hidden inside that bracket. We can't get at that one. Oh, so it has got a factor in there. I don't think it's useful at this moment though. We'll find it later on. So we've got a 2 there, 2 goes into 6, so let's put a 2 out there. And then we've got some power of 2r plus 9. And this is where it usually does your head in. Our instinct says we've got to take the one with the lower number, because every time we take out a common factor, it's always the lower of the numbers of the factors. And our instinct also says that 1 is smaller than 2. But we've got to suppress our instincts and realise that negative 2 is less than negative 1. So this, in fact, is the smaller, for want of a better word, factor. So that's the one that's going to go on the outside. So let's see what we've got left after we've gotten rid of all of that. So this first term is 6. We've already got a 2, so we need a 3. And then we've got 2r plus 9 to the negative 2. What do we multiply by that to get 2r plus 9 to the negative 1? Now I'm just going to write down here, just off the screen here, maybe over here. Let's have a little think about this. We've got something that has a power of negative 2. We want to multiply by something that has another power to get a result of something that has a power of negative 1. This times this new factor. This is the unknown we have here. Negative 2, a to the negative 2 times a to the what is a to the negative 1. Well, our index laws say that we've got to add these two together to give this. So negative 2 plus what is negative 1? Well, negative 2 plus 1 is negative 1. So this has an invisible power of 1. Let's continue. We've got a plus. We haven't touched this 6r minus 8, so let's touch it now. We still have a negative there that we haven't used, so I'm going to stick that on the front. And the 2r minus 9 to the negative 2, we've already counted for that, so we don't need that anymore. Let's go to the next line. Expand this. 6r plus 3 9s are 27. And minus everything in there. Minus 6r minus 8 is plus 8. Oh, looks like we've got some good cancelling going on here. So 6r minus 6r, gone. 27 plus 8 is 35. So times 35. Let's put that 2 and 35 together. And lastly, let's put it back with positive indices. So put that 2r plus 9. Oh dear, I didn't realise what's going off the screen. 2r plus 9 to the 2. I'm hoping that that's been useful for you. They are particularly tricky, so do practice a few of those.